Earth feels stable. The sun rises every day. The seasons follow predictable cycles, and our planet moves along a steady orbit that has remained consistent for billions of years. But what if that orbit suddenly changed? What if Earth were somehow ejected from the solar system, cast out into interstellar space like a rogue planet? The idea sounds like science fiction, but gravitational physics allows for such possibilities under extreme conditions. To understand what would happen, we must first consider how Earth remains in orbit. Our planet moves around the sun at roughly 30 kilometers per second. This forward motion balances the inward pull of solar gravity. If something disrupted that balance, for example, a close encounter with a massive object, Earth's trajectory could change dramatically. A passing star, a wandering black hole, or a massive rogue planet entering the inner solar system could, in theory, alter orbital paths. The probability is extremely low, but not zero over cosmic timescales. If Earth were suddenly freed from the sun's gravity, it would not simply stop. It would continue traveling through space at its current orbital speed, moving into the darkness between stars. The first and most immediate consequence would be the loss of sunlight. Within minutes, the sky would go dark except for distant stars. The sun would shrink to a bright point and gradually fade as distance increased. Solar energy drives nearly every surface process on Earth. Without it, temperatures would begin to drop rapidly. Within days, average global temperatures would fall below freezing. Oceans would begin forming thick layers of ice on their surfaces. Within weeks, most plant life would die, unable to perform photosynthesis. Food chains would collapse. The atmosphere would cool and weather patterns would cease. However, Earth would not instantly become a frozen solid rock. Our planet contains internal heat generated by radioactive decay and residual formation energy. This geothermal heat would continue warming the interior. The oceans would freeze from the top down, but beneath thick ice layers, liquid water could persist for millions or even billions of years. Deep-sea hydrothermal vents, already independent of sunlight, might continue supporting microbial ecosystems. Life would not vanish immediately. It would retreat underground and beneath ice. As temperatures plummeted, atmospheric gases would begin to condense. Carbon dioxide would freeze first, followed by oxygen and nitrogen at extremely low temperatures. Eventually, much of the atmosphere could settle as frost on the surface. The sky would no longer be blue. It would become black permanently. Stars would shine with unprecedented clarity, unfiltered by scattered sunlight. Earth would transform into a wandering frozen world. Gravity would remain unchanged. The moon would likely continue orbiting Earth, and tides generated by gravitational interaction could provide minor internal heating. Over time, Earth would drift through interstellar space, becoming a rogue planet, but survival would depend on how long complex life could endure the absence of energy from the sun. As centuries passed, Earth's surface would stabilize at temperatures far below minus 100 degrees Celsius. Oceans would be sealed beneath kilometers of ice. Continents would become frozen deserts. Yet, deep underground, life would persist. Geothermal energy would create pockets of warmth in caves and beneath ocean floors. Certain extremophiles on Earth already survive in environments without sunlight, relying on chemical energy instead. Humanity, if prepared in advance, might attempt to survive through artificial habitats powered by nuclear reactors or geothermal systems. Massive underground cities could theoretically sustain life for generations, insulated from the frozen surface. But over longer timescales, challenges would intensify. Nuclear fuel is finite. Infrastructure would degrade. Maintaining technology without external resources would be increasingly difficult. If Earth passed near another star system, a rare but possible event over billions of years, gravitational capture could occur. Earth might become bound to a new star, reigniting warmth and potentially restoring habitable conditions. Such a capture would be extraordinarily unlikely, but not impossible. Alternatively, Earth might drift indefinitely through the Milky Way, orbiting the galactic center every 200 million years without belonging to any stellar system. Interestingly, studies of rogue planets suggest that thick atmospheres could trap geothermal heat effectively. If Earth retained enough atmospheric pressure before freezing, internal heat might sustain subsurface oceans for billions of years. In this scenario, microbial life could continue long after surface ecosystems vanished. The ejection of Earth would also alter the solar system itself. Without Earth, gravitational dynamics among remaining planets would shift slightly. The Moon, if separated from Earth during ejection, could become its own rogue body. The psychological impact of losing the sun cannot be overstated. Human culture, agriculture, and energy systems are fundamentally tied to solar cycles. Without sunrise, the concept of day and night would vanish. Timekeeping would depend entirely on artificial systems. The stars would no longer rotate across a bright sky, but remain fixed against eternal darkness. Eventually, over billions of years, even geothermal heat would decline. Earth would cool further, becoming a dark, inert planetary remnant. Yet even in such isolation, the planet would remain part of the galaxy's gravitational dance. It would carry within it the geological record of oceans, life, and civilization. The thought experiment reveals how delicately balanced habitability truly is. Earth's position within the solar system is not merely convenient. It is essential. A slight change in orbital energy could transform a vibrant biosphere into a frozen wanderer. And yet, the possibility that subsurface life could endure reminds us that life is resilient. The universe contains countless rogue planets drifting between stars. If Earth joined them, it would not explode or vanish. It would simply continue moving through the cosmic night, a silent traveler once warmed by a star. The scenario underscores both the fragility and persistence of life, and the extraordinary importance of the sun's steady light in sustaining our world.